I'm going to show you some examples of how we can work out the gradient of a line, and we're doing this in context of the general form for the equation of a line, which is y equals mx plus c, where m is the gradient. Now, another word for gradient is slope or rate of change. We're looking at, for every step forward, how many steps up or down do we go? That tells us what the gradient is. It's useful to remember that if we have a line sloping upwards or forwards, then our gradient will be positive. If we have a line which is sloping backwards or downwards, then the gradient will be negative. Okay, the formula, there's lots and lots of formulas, but just to remind ourselves that the gradient will be the difference in the rise over the difference in the run. So we can do this if we've got a graph. We can draw a triangle on. And in terms of how do you draw the triangle or decide where to place the triangle, you just want to place it so that the points on the graph are where the grid lines intersect, because then it's easy to count along. Okay, so in example 1 in A, I am going along 1, and then I go up 2. And this pattern repeats as I go, as I would increase along the line. The gradient is the same along the whole line, it doesn't matter where you draw this. So using our formula, rise over run, the rise is 2 over the run of 1. So the gradient of line A is 2. Now line B, slightly shallower incline. This is steeper for A. So this is likely to be less than 2. So let's just draw a triangle in. I think I will do this one. So again, choosing these points here. The rise in this case is 1, and then the run is 3. So the rise over the run, rise is 1 over the run of 3. So the gradient of this line is a third. Leave it as a fraction, it's much easier than putting it as a recurring decimal. Okay, let's look at line C. Now straight away, line C is different because it is backwards sloping. So that tells me it's going to have a negative gradient. So let's just draw a little triangle on again, choosing sensible points. So now I've got a run of 1, and then, well, it's a rise, but we could look at it as a fall of 3. So the rise is 3 over the run of 1. So line C has a gradient of negative 3. And it's negative 3 because it's backward sloping. Okay, let's have just a couple more. For line D, along 1 and up 1. So the rise is 1 and the run is 1. So that is a gradient of 1 and a positive 1 because it's forward sloping. And we'll just look at E rather. Now this is a backward sloping line, so straight away I know it's going to be a negative gradient. I've got a run of 1 and a rise of 2. So the gradient would be rise over run, and it's a negative 2. Okay, I haven't gone through all the examples. No one wants to watch me do all of that. Hopefully that's given you some idea of how to work out the gradient, and I'll just show you a few examples of how we apply that to finding the equation of a line. So remembering y equals mx plus c, and the gradient is going to be the rise over the run. In this example here, again, I'm going to draw a little triangle in. Doesn't matter where you draw it. I could have chosen to draw a bigger triangle. Let's do that one. Okay, just to show you the gradient would be the same. So the run is 2. You do have to be careful. Look at the axes because they won't always be, each square won't always represent 1. So it's really important you check that. But in this case it does. And then the rise, 1, 2, 3, 4. So rise is 4 over the run of 2, which gives me a gradient of 2. So I know the equation of the line is y equals 2x. The plus c is where it crosses the y-axis, and it crosses the y-axis here at positive 2. So the equation of this line is y equals 2x plus 2. Let's have a look at this line. Draw a little triangle here. So I've got a rise and a run of 2. So the gradient is 1. Now, you don't have to write 1x. You can just write y equals x, because that is 1x. It's not wrong if you do write the 1, but you don't have to put it in. Let's have a look. Where is it crossing the y-axis? At negative 4. So that's the equation of this line. A couple more. This line, let's draw a triangle in here maybe. So the run is 2, the rise is 1. So rise over run gives us a gradient of 1/2. So that is y is a half of x, and it crosses the y-axis at plus 1, positive 1. Now, half of x, you can also see that as written as x over 2 plus 1. And if you want, you can write it as the decimal equivalent. Okay, 3 ways, all meaning the same line. Now, the final one, again, is backward sloping. So we know we're going to have a negative gradient, but let's just see what that gradient should be. So let's draw a triangle here. So I've got a run of 2 and then a rise of 4. So rise over run tells me that this is going to be a negative gradient of 2. Should really put a negative 4 there, because it's not an increase, it's a decrease. Okay, so my gradient is negative 2, so y equals negative 2x, and it passes through the y-axis at 4. You can also write it like this. Some people prefer to write it like this because then it's more clear for some people that that is a negative 2x, so it will be a backward sloping line. Okay, time for you to go and do some practice yourselves. I hope this has been helpful.